No. Okay. So what we're talking about, what we talked about yesterday, is like when you have to calculate mils needed for a patient, tablets, um, how many tablets to go home. And yesterday I sent you that little brief study guide that worked through like that's how I work through my steps. You know, what is the dose needed per dose? How many doses a day? And then how many days are we doing the treatment? And that's how we figure out how many pills to send home or how many mils they need to. Um, yeah, Francesca, after I get through this PowerPoint, we're going to go through some problems from the homework at the end. So we'll get back to that. Okay, so when we're talking about a solution, it's typically going to be something is being dissolved in like a water or an alcohol. So we need to dissolve something into a solution. So the chemical is the solute, and then it's being put into a solution. So a solute is being diluted out. Let me think of it this way. When you make soup and you add a packet of seasoning, okay, you have maybe a pot of water. That's your solution. Your solute is the little packet of seasoning that you're going to put in, and then that packet is going to be dissolved or it's going to be spread throughout the solution. Normally, we express this typically either a fraction or a ratio. We want to make, a 25% solution, which is a quarter of whatever we're doing. Usually we're speaking of things in 100. Okay, so being fairly comfortable going from a fraction to a percent is somewhat key. Now, when we get to the end, it's like, what is the concentration now of the packet now that we've put it in a solution? Okay, when you have a little packet of seasoning, that's very concentrated. But when we put it in the soup, we're going to dilute that out. So now we're trying to express what is the percent now that it's mixed with this solution. So on the bottom here, if you can see the gray box on the screen, we have they're represented as a percent of the total solution. So that's always going to be times 100 because percents are in 100. Yes. So JC, like when we get rescue, and that's a good point that you brought up, some of these cleansers that we get, like I don't think we use Rocal anymore, but rescue comes in a very concentrated, it's very concentrated. You wouldn't pour straight rescue in a bottle to clean the tables in our classrooms or to clean the kennel. So typically you're going to add a little bit of rescue to a bucket of water or a bottle of water to make a spray bottle. And normally the bottle will tell you, or normally your clinic will list formulas to say, to make up a bottle, put in this much, to make up a mop bucket, put in this much. Yeah, rescue is very strong. A lot, when I was in school or I was in kennels, we used Rocal, and it was this very deep, green, thick liquid. It was supposed to basically look light green in water. The darker green it was, you used, and it was very irritating. If you breathed it in, you would start coughing. It would burn your throat. So yeah, a lot of these, they have to be diluted out and to make a solution of rescue or cleaner or whatnot. It's kind of like getting a container of that Lysol and you add it to a mop bucket. You're not going to usually mop with straight Lysol liquid. You're going to dilute it out to make a solution. So if you look at here, you've got the concentrated solute, you've got the solvent, and you have what is your desired solution. Now, when we make a mop bucket, are we measuring how much water's in the bucket? We're just, sometimes we just get an idea. But when you start working with medications or, a spray bottle is a defined amount. If you wanted to make 1,000 mils, okay, we want 1,000 mils total volume. We are going to, if we have 108 mils of solute, which is the chemical, we are going to add that to 892 mils of water, because if you added 108 mils to 1,000, you get 1,108 mils. You need to make the total 1,000. Say the bottle only holds 1,000. You can't add another 108 mils. So normally when we add a solute to a solution, we pull out from that volume, we pull out whatever we're adding. If I'm adding 50 mils to a bag of saline, I pull out 50 mils of saline, add 50 mils of my drug, if that makes sense. So what you're going to end with is typically 1,000, or however many mils you want to make. If you need 40 mils and you have to add 20 mils of drug, you're going to pull out 20 mils from that bottle and add 20 mils of drug. So that's just telling you, when you work with solutions, you're going to have an end volume. You need to subtract from the end volume whatever you're going to add to it, so you don't go over that defined amount. Now, when you work with solutions, sometimes those come as a percent. If you were trying to make a solution of lidocaine, lidocaine is a 2% solution. And then percent is how much of drug in 100% of that volume. So right now they're telling you in that bottle, there is only 2% of lidocaine in 100 mils of lidocaine. Or in here, it's 50 mils of lidocaine. Okay, so remember, percent is always grams of drug per 100 mils. So if I look, okay, I have 2 grams of drugs per 100 mLs. Now, ignore the fact on that bottle it says 50 mils. You always figure out the percentage based on 100, okay? Oops, sorry. So what we're looking at, it's just telling us 2% tells me there's 2 grams per 100 mils, and then you're going to have to solve. But what this means is this drug right here is actually, remember we said we add a 0 or we multiply by 10. So 2% is 20 milligrams per mil. Then we can figure out the milligrams and mils after that. Okay. Now below here, it talks about, on the bottom of this slide, ratios or fractions are translated into percents of a solution. So if you have a 1 to 1,000 epi, we're going to divide the 1 by 1,000. You multiply 100, and that's going to tell you the percent of epi. Okay, because a 1 to 1,000 solution, we're like, what percent is that? 1 divided by 1,000 is 0.001 times 100 would equal 0.1%. So we know there's 0.1% epinephrine in that solution. And there's going to be a picture of that bottle coming up. So we've already done this. Percent of solution times 10 gives you the milligrams per mil. Mgs per mil, if you do that times 10, gives you the percent. It's a way to work back and forth within that number. I don't want this to be confusing. It's literally just telling you, you can convert it this way. Or if you had a mgs per mil drug, you can multiply the milligrams by 10, and that would tell you what percent of drug is in that bottle. Okay. Solutions.
So I have a question.
Hello, yes.
So a 4% solution would be 4 grams over 100 milliliters, and then 40 milligrams over 100 milliliters.
Actually, when you add the 0, then you're only over 1 mil. So 4% is 4 grams over 100. And then technically when you set it up as a problem, 4 grams over 100, which is
Okay.
40 grams, I'm sorry, 4 grams over 100. If you multiply that by 100, then that you would add the zeros and you cancel them out, which equals 40 milligrams per mil.
Per 1 mil.
Per 1 mil. When you first,
okay.
Yeah, when you first look at a percent, it's always grams over 100, but then you're going to basically the fast way is to add a 0 to that, and that always gives you mgs per 1 ml. I can show
Okay.
you at the end how I set that up, and I cancel out the zeros. I did one, but it on that study guide I sent you yesterday, I did kind of work out one of those problems.
Right.
Yeah.
All
Okay.
right. Thank you.
Yeah, we'll come back to some more. Don't hold that thought. But so when we're looking at a solution, which typically we're talking about liquid and liquid, we also can do solid and solid. 1 mil per 100 mils, 5 ounces per 100 ounces, 15 liters per 100 liters, is we're typically working in hundreds. We're trying to keep everything even. Okay. Remember, you always want to be working in the same units when we set up these problems, because if you figured out your percent as grams per 100, but you needed mgs per mil, you have to convert those grams. That's why going back and going back and forth is setting them up is important. Now, when we talk about weight, 60 milligrams per 100 milligrams, 4.5 grams per 100 grams, it's always being whatever, if we're doing weight or volume, we're always speaking of how much in 100, how much in 100. Okay. So that just gives you some examples underneath. Now, solids and liquids is when we're working with how much to add to the fluids. The percent concentration, the weight in grams per 100 mils of volume. So if we look at, and this is super common to do, weird thing when you're in a clinic, a lot of times we have to give a puppy that's hypoglycemic dextrose or sugar in their fluids. Most of your fluids don't come with enough sugar added. So a lot of doctors are saying, let's add dextrose to, maybe Baxter's fluids. Okay, I want to make it 5%. Or when we look at the bottle of dextrose, if I look at it and the dextrose says it's a 5% solution, because dextrose comes as a separate bottle, I know that dextrose is 5 grams per 100 mLs. And then when you further convert that, and Brittany, this is probably going to answer your question, 5 grams over 100 mils equals, I got to convert grams to milligrams. So I multiply that by 1,000, because there's 1,000 milligrams in 1 gram. So there's 5,000 milligrams per 100 mLs. The problem is that is a fraction that has to be reduced. Remember, you always want to get down to 1 or its simplest form. Well, the easy way to do is this should normally be over each other. So if I had 5,000 milligrams over 100 mils, if you cancel the zeros, there's 2 zeros on the bottom. I take away 2 zeros on the top. I'm left with 50 mgs per mil. Okay. That's in a 5% dextrose solution. Now, we're going to get to how do we make a bag of fluids. So here's a 50% dextrose solution. This is how it comes from the manufacturer. If you have here, the first thing is this should say 50. This is 50 grams per 100 mils. And then we're going to say how many per mil, how many grams. Well, if you take off 50, take off 2 zeros or move the decimal point 2 places, this would be 0.5 grams per 1 ml. Now this has just been reduced at a different time. And then our next one would be how many mgs per mil. Well, you're going to multiply that 0.5 times 100, and you would get 500 mgs per mil. But again, if I see this bottle, I know that my shortcut is to add a 0. So a 50% solution is automatically 50 milligrams or 500 mgs per mil. Okay. Now, when we're talking about solutions and solutes, if it's a 1 to 1,000 ratio, that means one part of that is medication. 1,000 parts of that is fluid, so to speak.
So wait,
Yep.
how many mg are in a mil?
It depends on the medication. Mgs does not translate to milliliters. They're
Okay.
Okay, so like if I say, Brittany, go get me amoxicillin injection for this dog, I would look at the bottle and it might say 45 milligrams per mil. If my patient needed 45 milligrams, I know there's 45 milligrams in 1 mil, I would drop 1 mil. Does
Right.
that make sense? Your mgs per mil is different for every medication. It depends on that So you first figure out how many milligrams your patient needs. Then you go to find out what's the concentration of your drug. And then that's how you can find.
Right.
Yeah. Does that make
Okay.
sense? When we're talking about, this might clear up some confusion for people out there. If we're talking about a drug that comes in a percent, I don't know how many mgs per mil that is. That's why I have to figure out how many mgs per mil are in dextrose or lidocaine or Lasix. Those drugs come as percents. So before I can drop medication for my patient, I have to figure out, if it's a percent, how many mgs per mil is in that bottle.
And then once you find out the mgs per mil, okay. I don't.
Brittany, at the end, I'm going to work through one of those problems at the bottom on the homework. So it might make more sense. So hang tight on that question too, because if I'm talking about things that come as, if I have a 1 to 1/1000th epinephrine comes like this, okay? What we need to do is we have to say, what percent is that, okay? You take the part, you divide it by the volume, 1 divided by 1,000, you're going to move that decimal point, 1, 2, 3, okay? 1 divided by 1,000 times 100 would give you a 0.1% concentration of epinephrine. Now I've told you the next step is, if you have a percent of a concentration, translate that to mgs per mil. So then we're like, well, then how many mgs per mil are there in a 0.1% solution? On my gray box you should see underneath is that we know that we are going to move the decimal place 1 point or multiply by 10. 0.1% times 10 is 1 milligram per ml. So you see, I've started with a drug in a ratio. I've changed it to a percent, and from a percent, I can change it to a milligram per mil situation. Now this, I'm going to tell you, this doesn't happen with a lot of drugs. This is an epinephrine label. You can see epinephrine comes as a 1 to 1,000th injection. It actually, this is part of the label that goes around the bottle. It tells you right here, epinephrine contains 1 milligram. So some labels will tell you that, but with a percent, I always just work it out before I draw it up to make sure. Let me go to a percent solution. If you have a pure drug, a pure solution, now this could be like your, what I just say, rescue. You have your pure drug or your pure chemical, which is rescue. You have your stock solution, which is either your mop bucket, your spray bottle, or like in a lot of cases, a bag of fluids. There is a lot of drugs that we give animals inside their IV fluids so they can be diluted out and given over time. So sometimes we give dextrose in fluids, we give metoclopramide in fluids, and we have to figure out how much drug, pure drug, to add to a dilute solution to get what we need, okay? So we're always working with the stock solution is dilute, the pure drug is more pure. So you can put this in a ratio proportion, but let me skip forward. Well, let me show you something here. Okay. If someone says how much sodium chloride, NaCl is sodium chloride, we want to make a 500 ml solution of 0.9%. Okay. If I look at the gray in the bottom, now normally 500 mils is half of a liter. Okay, so what we're talking about is a 1 to 2. So it's kind of like transferring it to a ratio, which may seem confusing, but let me show you the problem here at the bottom. Okay, you want 0.9% NaCl. All right, if I set it up, how many grams of NaCl is needed to make a 5% solution? And what the solution needs to do is equal 0.9 grams per 100 mLs because I want a 0.9% solution. 0.9% is 0.9 grams per 100 mLs. If, now unfortunately on the computer I can't, it's not up and down here, but you would multiply 100x 0.9 times this, and then we're going to multiply that, and you're going to get 4.5 grams. So you need 4.5 grams of 0.9% NaCl to make a 500 ml solution. But let me skip forward something here because I mentioned this on the study guide. And most of the time we're working with V1C1, which is you have a volume and a concentration, and what is the desired volume and concentration of this. You have the volume and the concentration of the first drug, but we need to make the volume and concentration of the second drug. Okay, so V, we look at here, V1C1 could also be listed as the solvent and the dilution factor, okay? Beginning stock, beginning concentration, V to use the volume of this final solution and the concentration of the final solution. Okay, so if we go to the next slide, sorry, this is what it's all standing for. This is set up, sometimes we order formaldehyde in a more concentrated form because it's cheaper. And then we can add it to solutions to dilute it out so that because formaldehyde by itself would be way too strong. So in this situation, it says how much solvent and solute would you need if you want to make 500 mils of a 10% formaldehyde solution. Okay, so volume 1, okay, what we want to end up with is we want to end up with 500 mils of 10% solution. So that's going to be on one side of the problem. We have, what we have is we have a 50% stock solution. Okay, so volume 1 is how much of what we have, 50% is the concentration of the solution that we have. How much of that volume are we going to have to do to equal 500 mils of a 10% solution? So if we look in this, we do 500 mils times 10%. We look below here, you get 500 mils. We have 100 mils of the solute is the volume that we have. If you have 500 mils we want to end with, remember I said you don't want to go over the volume, so we would subtract 100 mils and we should add 400 mils of a solvent to make this final solution. Let's go through another one, okay? And this one is probably, I would say, the most common that we work with, because we carry 50% dextrose, most hospitals do, but you cannot inject a patient with 50% dextrose. That is completely way too high of a concentration. That's very dangerous. So when we give dextrose to a patient, if they come in hypoglycemic, we have to dilute it into a weaker solution so it's safe. And normally we give them in fluids, IV fluids, to be given over time. So if the doctor says you got this little puppy or kitten and they want the patient to get 250 mils and a 5% solution of dextrose. So right now in your hospital, you have a 250 mil bag of plain fluids and you have a bottle of 50% dextrose. Okay. So if you look at V1C1 here, okay, volume of what we have at 50%, but we want to make 250 mils of a 5%. Okay. So if we multiply this out, we're going to have to add 25 mils of a 50% solution, because if we go across 5% times 50, okay, is going to be over 250 mils. If we divide that out, we're going to get the 25 mils is what you're supposed to add of 50% dextrose. Now, remember, you're going to be pulling out 25 mils out of your bag of fluids and you're adding 25 mils because you need the bag to be a total volume by itself. I want to just mention something about this and then let me get to the homework sheet because I want to spend some time on that. Reconstituting medication, normally when you get a bottle of medication that's a powder, cefazolin is a common antibiotic that we use IV during surgery. It comes as little bottles of powder. When we go to use that, we're going to have to add fluid, usually sterile water, sometimes saline, to that bottle to mix it up into a liquid. Okay, and that's reconstituting a medication. When you guys send home amoxicillin, little amoxi drops for cats, that comes as a little bottle of powder, you're going to add a certain mils of water, shake it up, and then you're going to send it home with the owner as a liquid. When you do this, the label should always state how much fluid to add. And you always want to label it with the date and the time that you reconstituted it, because most of the time it has to be refrigerated and it has a certain shelf life. But let me show you this. Cefazolin sodium is the powder. It tells you right here, circled, to prepare, add 2 mils of sterile water or sodium chloride, and it'll give you 2.2 mils of total volume, which is 225 mg per mil. Now, if you need, sometimes doctors will add more or less, and they will change the final concentration. If you get that, you're going to get 225 mg per mil. 500 milligrams of drug. Now, again, because we're stressing math, there's a way to add the fluid. You add air to the bottle. We withdraw sterile water. We inject it into the bottle of our medication, and we reconstitute. Sometimes you get a drug like ampicillin. Ampicillin comes as 25 grams of a powder, and we can add sterile water to yield different concentrations. Sometimes we will add more or less if we want to extend its use. So if we add 104.5 mils, we get 200 mg per mil. If you add 75 mils, you get 250 mg per mil, and vice versa. Now, if you have a patient that needs 500 milligrams, and I have a bottle that's reconstituted with 41 mils of sterile water, 41 mils gives me a concentration of 400 mg per mil. And Brittany, this might go to what you were asking earlier, because you were like, how much ampicillin is my patient going to get? If I look below here, okay, my patient needs 500 milligrams. I calculated that based on my veterinarian's directions. The drug is 400 mg per mil. So every mil contains 400 milligrams. I divide 500 by 400 and I get 1.3 mils of total drug. So when you go to the bottle, as long as you made it up correctly, you're going to give that patient 1.3 mils, and that will give the patient 500 milligrams. Okay, let's go. The rest of this we are not doing. So let me go to, hang tight. I lost my mouse. There we are. Oh, here we go. Okay, can everybody see this? Math homework 1 was kind of straight conversions, kilograms to grams, you know, liters to milliliters, blah, blah, blah. You're going to get this sheet sent to you, but let's skip down to one of the problems that goes into solutions. Because I think, again, converting percents and solutions are probably a little more of the challenging stuff. There's a straight up problem. You know, if we have acute glaucoma, our vial is 20% mannitol. 20% mannitol automatically equals 20 grams per 100 mils, or 200 mgs per mil, because I add a 0 and that gives me mgs per mil. So a 20% solution is automatically 200 mgs per mil. So how many grams per mil? 20 grams per 100 mils. All you have to do is divide by 100. Okay, that gives you 0.2 grams. If I want to say how many mgs per mil is, then I have to convert grams to milligrams, and you multiply by 100. Okay. My dog needs 0.25 grams per kilogram of mannitol. Now, the doctor in this situation told you the dose in grams per kilogram. Sometimes they say milligrams per kilogram. This doctor said, yeah, I'm going to do that one next for sure. Okay. Number 24. But if you look here, if I need 0.25 grams per kilogram, okay, first of all, my patient's 25 pounds. So 25 divided by 2.2, okay, that's going to give me my weight in kilograms, which is not listed on here. Hang tight 2 seconds.
11.4 kilograms.
Thank you. So you have 11.4, and we're going to multiply that by 0.25, and that gives you 2.85 grams that the animal needs. I would first of all convert that to milligrams. So 2.85 grams times 1,000 is 2,800, and now that says 2,840.9 milligrams. We know that the drug, we've already figured out that it's 200 mgs per mil. Divide that by 200, and your patient's going to need 14.2 mils of mannitol. Okay. Thank you. I will totally.
So would 2,800 be an okay answer? Because
Yes. What I want you to
it would
know,
be 2.8.
when you guys do the math, you need to leave it in your calculator, because clinically you might draw up a different amount, but I need to know what you calculate in mgs per mil. So that's why I want to see it like that.
Okay.
Hopefully you guys can see. I got to get my chat screen back. Hold on. I lost my chat screen. There you are. Okay, thanks for mentioning that. Duh, I should have done that a long time ago. Okay. Nina, 24. Okay, 24. Yeah, I hate problems like this. I'm just gonna be honest with you guys. I do math weird. That's why I was intimidated. That's why I was like, if you want to ask another teacher, because sometimes I do it a really long way, and that's just what works for me. So hopefully this makes sense to everybody. Okay, 24. I have a 40%. I buy 40% formalin. Okay. I have to dilute it into sterile water. So my solute is formalin. My solution is going to be sterile water. So how much formalin am I going to put in sterile water? I want to make 25 mils of 10% solution. Okay, so I've got on one side, I've got what do I need? Okay, 40% solution. 40 is basically talking about what do I have? My volume 1, the concentration of that is 40. I want the second solution to be 25 mils, 10% over 25 mils. So you're going to put 10 over 25 because you want 10% solution of 25 mils, okay? And if I do volume over volume, then I get 10 times 25 is 250. So what I can do is I get 250. I divide that by 40. That tells me that I need 6.25 mils of my 40% formalin that I have. Now, I want 25 mils total volume, okay? I'm going to be putting 6.25 mils of formalin in there. So I subtract 6.25 from 25, and then that tells me I need 18.75 mils of sterile water. Okay, so that means in a 25 mil bottle, 18.75 mils of that is sterile water. 6.25 mils of that is formalin, and that gives me a 10% solution of 25 mils volume. If we want to make up 75, I know, Nina, I hate these are tough problems. I wish there was a super easy way to talk about it. I know some, let me see, 1 second. Okay, so let me go back to now for the next part of that problem. Sorry, let me move these out of the screen. Okay. The next part of that is I want 75 mils of 2% formalin, okay, for a heartworm lysing solution, okay? Now, I still have 40%. That's what I've started with. So I've got my 40%. I'm not sure of my volume. I don't know how much of that I need. So I have 40 with volume 1, but I know that I want 2% of 75 mils. So if I have 2 over 75, okay, 2 divided by 70, let me go up here, okay, 2 divided by 75, or 2 times 75, sorry, I get 150, and then if I, 40, and you can do this on your calculator, but I did this wrong. Josie, you may want to just have a little class with Josie here, okay? Volume 1 is I'm going to need, you have 2 over 75, 2, and you have 3.75 of 4% formalin. 75 minus 3.75 is going to tell you how much sterile water and how much formalin to make that total volume, okay? So 40.
What?
Yep. And then 40 Hang on. Let me go up here. I think this was set up wrong. 275. Oops. Sorry, 2 times 75 divided by 40. 2 times 75 is 150. Divided by 40% is what you have. You have a 40% solution of formalin. Gives you 3.75 mils. Okay. I was putting that in my phone backwards. Okay. So you have 2 over 75 is what you want. You want 2% solution of a 75 total volume. Okay. So 2 times 75 gives you 150. Now you have 40%. So you would take the 150, divide that by 40, and then that would tell you how many mils to add to how many mils of the stock solution you have, which is 40%, to add to 75 mils of solution, which is your sterile water. But again, remember I said, imagine you have a container that won't go over that volume. So you'd have to subtract what you're adding. So if you subtract 3.75 mils from your solution, you add 3.75 mils of formalin to the 71.25 mils of water. That gives you 75 mils total volume.
What?
Tori's got it written out here. 2%, 75, 40 over X, cross multiply and solve for X. Yes. What's really strange, and this is what I hate right now, is sometimes typing it versus kind of writing it on a board. My board is not showing up really well. I bought my little board here, but if you've got and then you have I'm writing it out 1 second, so maybe it'll help to look at it. Is you have oh, it's still not showing up great. I apologize. And hopefully everyone's seeing what Tori typed, if that helps to kind of spell it out that way. Let me talk about the next one briefly and see if that works with the C1V1, because I think 25 and 26. Well, right. I mean, you are multiplying 2 times 75, which gives you the 150. And when you divide that, yeah, this is, let me just make that statement. People set it up differently. And this is where the dimensional analysis versus the working it across sometimes cause confusion. Yeah, if you're doing it in ratio form, but what this is showing you, if you go back to the initial problem, you're putting the solution that you want, the concentration you want is 2% of 75 mils. 2 times 75 gives you 150. You divide that by the percent of the solution that you have, which you have 40%. And that's going to tell you how much of the 40% to add to make the new solution. Let me give you that. Let me talk about 25 for a second, because you have a 1 to 20 solution of sodium chloride. Let me see if I can scoot this. Let me scoot my, so you can see the problem, sorry. For number 25, you have a 1 to 20 of sodium chloride. How many mils of water to dilute it? So you have a 1 to 40 solution. You have to change the ratios to a percent. So if you take 1 divided, if you have a 1 to 20 solution, you put 1 over 20, which then you're dividing 1 by 20, and you multiply that by 100. So if you literally do it, and like I said, some of you that are super fast at this is me doing it the slow way. 1 divided by 20 in your calculator gives you 0.05. Multiply by 100, that gives you 5%. So that means your 1 to 20 solution is a 5% solution. Okay? You want to get it out of a ratio and into a percent. So we're going to take a 5% solution, and we are going to, we want a 1 to 40 solution. 1 divided by 40 times 0.025 times 10 gives you a 0.25%. Maybe your board is, I don't know how to make you bigger, Josie. I can see it. Let me unmute you. Oh, I tried to unmute you. Okay, sorry, you're unmuted.
How I set up number 25. So I did the 1 gram per 20 milliliters to, I set it up as a ratio, but that's just filled in, to 100. Then I cross multiplied and divide, and I got 5 grams per 100 milliliters, which is 5%. And then I did the same thing again for the 1 gram per 40 milliliters, and I got 2.5%. So when I set that up as the volume concentration ratio looking thing, whatever you want to call it, V1 times 5% is the same as 1,000 milliliters times 2.5%. So I took 1,000 times 2.5 divided by 5, and that gave me 500 milliliters of NaCl. Then I took the volume that would be my end volume, so V2, subtracted that from V1, and that gave me 500 milliliters of sterile water that would need to be added to make 1 liter of 2.5% NaCl solution. Did that help anybody?
Oh, I mean, it's definitely, I know that is helpful, Josie. And, I'm recording this so everybody can go back and review that and look at that a little bit closer to see if that makes more sense. Okay, because yes, if you're going to just do it, whenever you see a ratio, you just want your head to go, I have to convert it to, yeah. And any ratio, you divide 1 by the number on the bottom, and you multiply that by 100, and that will give you a percent. And again, like Josie just said there, anytime you have a percent, your percent is always grams over 100. So any percent can then be converted into a volume. Like what she's saying here. Now that to me, I like to work long ways. I like to work it through. So a 5% is always going to be the 5 grams over 100 mils, and 2.5% is going to be 5% is grams over 100 mils, 2.5 grams per 100 mils. But if you work it out this way, you've got, you have you want the 2.5% over 100 or 1,000. This is how it works out. So it works out to be the same answer. She worked it out set it up in a different way. Does that make sense? Yes. And okay, let me just talk, since I know we're kind of, if we're at the, let me just say this, if we're at the end and you need to bop off, feel free to bop off. If you can stay and be helpful, I would appreciate it. I'm going to, when this is done, I will be sending out these homework keys, so you'll have these answers. And then if you want to contact me later, we can go over, maybe more in depth. But again, if you want to bop out now, feel free, as long as you typed here in the chat, but I'm going to keep talking. Okay, for 26, because Francesca, you had a question about that. It said the dosage for insulin is 0.5 units per kilogram is what the doctor wants. Your insulin is 100 units for every 1 ml. 1 ml contains 100 units of insulin. How many mils do we draw up for a 10-pound cat? The first thing I have to do is the doses in units per kilogram. So I'm going to divide, and sorry, my phone keeps turning off. 10 divided by 2.2, my cat is, I'm going to type. So my cat is 4.5 kilograms. That's not on the math problem there. Okay, so my dose is 0.5 units per kilogram. So 0.5 times 4.5. I know my cat right here is going to need 2.25 units. Okay. Insulin is 100 units per ml. So you have to divide the milligrams or the units needed by how many units per mil. So 2.25 divided by 100 should equal 0.02 mils. So you would draw up 0.02 mLs and give it to that cat. But the first thing you have to do in that problem is basically convert your pounds to kilograms so that you can work in kilograms. Thank you. I should have read out the whole thing. I was trying to be fast. Okay, who wants to unmute and ask some questions? Brittany, I want to go back to something you were asking me, but I'm trying to remember your question.
I think that, for the most part, like I'm getting it, I'm understanding when it's one problem, but then when we move on to the next, it's like I forget.
Yeah, and are you talking about when there's multiple steps in a problem?
Yeah, like when it's like the percentage and yeah, just having to convert and having to, the V1, V2, C1, C2, that confuses me so bad. Like,
think about it this way. I think the simplest way to write it up when you have a problem like that, if I go back to let me go back to 24, okay?
okay.
You have 40%. I want 25 mils of 100 or 10% solution. And what we end up doing is you multiply the mils that you
by that
want.
percent.
Yeah, so 25 times 10 gives you 250. And then you divide it by the percentage of the solution you have. So 250 divided by 40 gives you 6.25 mLs. The added problem there is that if you had, you want 25 mils, if you're going to add anything to 25 mils, you're going to go over 25 mils. So you always have to take out from the 25 mils what you're going to add. Like imagine if you were
Okay.
like filling, okay, if you were making a drink and you filled up like tonic water to the top, but now you got to add your vodka. Wait a minute, I got to pour out a little bit of tonic water to add my vodka.
Right.
Or any container. If you are like adding, like if I pour a cup of coffee and I add cream and sugar, I got to leave a little room at the top so I can add my cream and sugar so I don't go over the top. So whenever,
Right.
so for IV fluids, dogs, normally a bag is a liter. If I'm going to add dextrose for a puppy to a bag of fluids, if I put in a bunch of extra fluid, that bag is going to be like bursting at the seams. So I got to take out what I'm going to put in. Your total volume always has to be what you're ending up with. So
Right.
once you give me the answer to that problem, that's a good answer. But then you have to subtract, say, I'm going to add this much to this much, and that's going to total 25 mils. Does that make sense?
It does, but then I feel like if you were to put it in a different problem, that I would forget it. Like take that problem and put it and make it into a new problem, and I feel like I wouldn't be able to do it again.
What you might want to do is write yourself out like the steps. Say, what do I have? Like, what do I want? And then what am I going to add? And what's my total? If you maybe make a little card that gives you those little steps. So then when you get a new problem, you can make sure you've solved for each of those steps, maybe.
Okay, and then another question about a different part of the math. It says, okay, you have a 50-pound dog. It's number 13.
Okay.
You have a 50-pound dog that needs an antibiotic. The DVM orders the patient to receive the drug cephalexin at 22 milligrams per kg BID for 10 days. Cephalexin comes in 250 milligrams, 500 milligram capsules. Okay, so the first one is how many kilograms does the dog weigh, which is 22.7.
Yep.
How many milligrams will the dog need for one dose? I put 22 milligrams per 22 point. So would I times those two or divide those two?
You're going to multiply the doctor wants you to use 22 milligrams per kilogram. So you're going to multiply what the doctor wants by the weight. So yeah, 22 times 22.7.
Okay, so I got 499.4. Now, should I have rounded that up?
No, this is where if you wrote 499.4 on a piece of paper, that's fine for your math. And then what they're telling you in the problem is that you're going to now go into the pharmacy and try to find which cephalexin you're going to send home. You have 250 milligrams and 500 milligrams. Well, 500 milligram capsule is closest to the 499. So we would just send home 500 milligram capsules. Does that make sense?
Yes.
So the way I think about which capsule to choose is how many pills do you want to shove down your dog or cat's throat at once? So
right.
Go with whatever dosage is easiest to give and closest to the correct dose.
Right. And
right.
It's easier to give one 500 milligram tablet than it would be to give two 250s, just because I don't want to fight my dog or cat to give him multiple of the same thing when I could have given him one of one thing, if that made any more sense.
Yes.
Yes. And that's so the thing is when you calculate the dose, whether it's going to be for a pill or a mil or whatever, the dose isn't always pretty with what you have on the shelf.
Right.
So and then this is the point where I go back to my doctor. If I got some funky number, I'd be like, what do you want me to send home? Do you want to go up and go with the higher? Maybe it goes over what you calculated, but it's easier for the client. And a medication like cephalexin, probably not a big deal. Sometimes it's a sensitive medicine and the doctor said, no, let's send the lower amount home. But that's where the doctor comes in. I will calculate it and say, which one do you want? Because some pills, you have a variety of choices. They come, like Rimadyl comes 25, 50, 75, and 100 milligrams.
Right. So, like number 15, for example, it says the DMV prescribes Cimetidine for a 30-pound patient, but can't,
Yep.
yeah, but can't remember the dose. The dose is 5 to 10 milligrams per kilogram. Okay, so the kilograms is 13.6. Now, I picked 7 milligrams. Is that kind of what you wanted? Like just a mid, or like what did you mean by what range of doses would be appropriate?
Well, so when we talked about ranges, you always calculate the low end. So I would calculate in the problem here, it calculates 5 mg per kg and 10 mg per kg. So for this dog, you know that your dose is going to be somewhere between 68 milligrams and 136 milligrams. So
right.
then if my dose comes as 200 milligram scored tablets, which means they can be cut in half, which range, where in my range would my best dose come from? Well, if I have a 200 milligram tablet, I can cut it in half, and that means half a tablet is 100 milligrams.
So around 7 milligrams would be a good range.
So
because I got 7 milligrams, and that's 95.2 milligrams for the animal.
So what she's wanting you to do is do calculations for both the low dose and the high dose.
So do 5 and then do 10?
Yeah, and so you'll have one answer for the low dose and one answer for the high dose. And then on part C, it says, oh, well, they come in 200 milligrams scored tablets. How many would you give to stay in that range? Well, the high range is 130 and some change, and the low range is 60 something and some change. But if you can break the tablet, which you can because it's scored, you can give them 100 and you're still in your dose range.
So you would do less than 1. Would that be the answer?
You just put literally half a tablet.
Half a tablet.
You have to think, and in this scenario, it's like, think like what's going to be good for a client to do. Well, it's, like I said, you're either going to give a half a tablet or a whole tablet. Well, a whole tablet is over your dose range. 200 milligrams is too much for this dog. The next, and Brittany, in a clinic, I've done what you've done. Sometimes I calculate the one, I pick in the middle. Sometimes I see which one.
That's what I wanted to do.
On the problem, I just wanted you to do low and high, and then see where that pill would fit with your dose. Like Josie said, it's a scored tablet. If I break it in half, it's 100. 100 is within my dose range, so the patient's going to get adequate dose.
Right.
And then, do you understand further on the problem? The doctor, so we know we're going to do a half a tablet, so the dog's going to get a half a tablet, which is 100 milligrams. And then if I go down, they want to treat this dog TID 3 times a day for 6 days. Well, I know if he gets a half a tablet every
24.
Go ahead. Is it 24?
Well, no, I was thinking of a different number in my head.
Okay. Well, okay. First of all, I think about what does he need a day? If he gets a half a tablet 3 times a day, that's 1.5 tablets. Does that make sense? Because you give a half in the morning. Yeah. So I know I need 1.5 tablets times 6 days. So 1.5 times 6 gives me 9 tablets. So I need to give the client 9 tablets so that the client has enough to give her dog a half a tablet 3 times a day for 6 days.
Right.
Does that make sense? But I literally just do it in steps. Like sometimes when you read the whole problem, you don't just back up I go, I can only do one thing at a time. I did on your study guide, sent you how I do this step by step. How many kgs is my patient? How many milligrams does he need? What are the strengths of the tablets? What does the animal need per day? What does the animal need per regimen? How many am I going to send home? Okay.
Okay. So where did you get where did how is E done?
So,
because I got 95,200, so that's not even close.
you went the wrong way. Probably. Okay. If you've already figured out that this dog, it says if it comes in at 150 mg per mil, what range of mils could we give this dog based on the ranges you calculated? So like what Josie was saying, you calculate.
Oh, so you took your low dose and calculated it, and your high dose and calculated it.
Yes. So this dog is going to get anywhere from 0.45 mils to 0.91 mLs.
Okay, that makes sense.
Yes. So if given a range, the easiest way to do it, I've done it complicated. I've sometimes calculated for multiple doses. If you calculate the low and you calculate the high, then you know the low end of milligrams and high end of milligrams, and you can figure out a dose that fits best for the patient.
The pill.
For the pill. Now, mils,
right.
Then you know the patient's going to get somewhere in this mils. And then you could go to the doctor and say, this is what I calculated. How much do you want Fluffy to get? Oh, give Fluffy this much. You did your job by calculating. The doctor needs to do his job or her job and tell you how much they choose.
Okay.
That makes sense?
Yeah, it does.
Okay. And then, do the other ones make sense to you? Or those the hard ones to figure out?
Well, 16 and 17 I kind of struggled on, but I felt like it was just because I was trying to overthink it since all the other ones had so many steps and stuff. So I don't know if I got those ones right.
If you notice, kind of they build in complexity. So we start off with kind of simple calculations, and then we build the problem into more steps. And the ultimate is if a doctor says, Brittany, I want acepromazine 2 mg per kg for Fluffy to go home for 7 days, you may have to work that whole thing out in that type of way. So,
right.
Yeah. Sometimes it's very simple to calculate one thing and just be like, you just give me milligrams. But in a whole like story problem, the doctor's going to give you that dose, and the end result is sending pills home with the client. So how do we figure out?
So you always take, okay, so like on 16 it says Cooper, stop. It says it's 1 cc per 10 pounds. And then you find out that your dog is 33 pounds. So you always divide the pounds, or you times the pounds?
Yes, so it's 1 mil per 10 pounds, and our patient is 15 kilograms. So I got to get my patient to pounds. So 15, you multiply by 2.2. So now I know, so my patient's 33 pounds. And then I need to find out how many 10 pounds are in 33 pounds, because it's 1 mil per 10 pounds. But my patient, so if you divide 33 by 10, there's 3.3 10 pounds and 33 pounds. Does that make sense?
There's 3.3 pounds. And wait, say that one more time.
Okay, if I have a dose that says 1 mil per 10 pounds.
Right.
And then I have my weight in pounds. I have to figure out how many 10 pounds, because we're giving a dose per 10 pounds. So how many 10 pounds
Right.
are in 33 pounds? That would be 3.3.
Oh, which is how many milliliters? Okay, that makes sense.
Right. Because, and this happens when we do anesthesia, ketamine Valium is usually 1 mil per 20 pounds. And a lot of times, so some drugs you're going to figure out straight mils, you're not going to figure out milligrams. Now,
Right.
eventually, I'm not going to talk about it right now, but eventually you'd have to go back and figure out, because you have to record the MIGs in the chart. Then you'd have to go back and write that down.
Right.
But at the moment, yeah.
So does this have like I'm gonna get better at it once like I'm out in the field and I do it every day type thing? Because
Yes.
I feel like for you guys, for you teachers, I feel like you all have your own ways of doing it, and like you guys all explain it really good, and you explain it like it's really easy, but it's like it's really hard once you really start to like do it.
Well, I'm like, I was kind of joking with you guys. I said, trust me, when the doctor comes up, he might come up to me and say, Christine, I need to give this dog a 2.5% dextrose solution. I kind of freeze in my steps and I go, and then I'm like, hey, Jen, or hey, Aaron, come here, like, help me figure this out. I can tell you
Right.
that sometimes when we have to do this complex math, 2 or 3 of us kind of come together and be like, what'd you get? What'd you get?
Right.
And I'll always go to the doctor and be like, is this right? Because this is what and no boss of
Right.
mine has ever been like, oh my God, I'm not checking your math. I mean, everyone just kind of like jumps in and says, let's try and,
Right.
yeah. But I will tell you, Brittany, every test in pharmacology too, there will be math on it. Gillis is teaching you, I used to teach it. But we put some problems on so you guys keep practicing. In anesthesia, I put math on not every test, but some tests. And then radiology too, you calculate drugs, surgical nursing, so we keep putting it in different classes. And then in the clinic, you're going to get used to doing it. So it will
Right.
get better.
Right.
But I'm going to tell you, I do MIG per kg math almost every day. I only make up solutions here and there. I don't do that a lot. And it's hard for me too. Like, I'm intimidating teaching this right now because I know that I have struggled at times to do this myself. And I do it a weird way, like you said.
Yeah, and that's the thing with math is there's so many different ways of doing it that can start being confusing as well.
If you have a way that works for you, because some people give their shortcuts and they look at me and go, why do you put all those steps? And I'm like, that's how I learned it. That's
right. Like I need that.
If you need to write out multiple steps, I have no issue with that. As long as you get me the right answer, and if you can explain how you got your answer, that's all that I care about. Then I have something to work with. Does that make sense?
Yeah.
Yeah. And that way,